that the word average can mean up to 3 different things. As a matter of fact, it can mean up to like a dozen different things. I've chosen to ignore the other like 9 or whatever it is. So let's get back into this. And let's talk about which measure center makes the most sense. Okay? Here's a random sample of 100 men, American men, and their LDL levels. What's great about government websites is there's tons of data like this floating around that you can poach from. Love this. Maybe I'm in there, I don't know. Frequency axis, I didn't label it, I apologize. This is number of men in each given category. So, an LDL down at the bottom there, this is LDL in milligrams per deciliter. LDL, what is it? Low density lipid. Lipoproteins. Thank you. It's cholesterol. We're going to go with Sean understands it's bad cholesterol. It's the stuff you don't want. You want a low value of this.
You want to lose it.
That's
a bit, just
lipoprotein. Thank you. Said the wrong thing for like 15 years now. So you want lower LDL levels. You want higher HDL levels. You want a good ratio. All that. Get the stuff tested. Get the stuff tested. Usually they'll do free tests through school and through OSU probably does something like this too. The wellness check. A lot of times health insurance plans now don't charge you for yearly annuals, which is a very, very good thing because it saves, well anyway, that's a math problem. There's a math problem in that too we'll get to later on. But anyway, here, this is the data I was able to collect. These are the guys that had LDLs below 3.25 milligrams per deciliter of blood. These are the guys that had milligrams between 3.25 and 3.75, 375, 425, you see how it just keeps going. They're in half milligram increments as it goes down. So, and you understand the frequency axis, right? Like, so there's about 32 dudes in that range there. Looks like about 20 dudes in that range there. These guys gotta start watching their diet, right? Right? Maybe. It depends. I have to know what the cutoff level is for too high of an LDL level.
It wasn't very good odds because there's only 2.5 of them.
Well, good. Assume this is a representative sample, right? Assuming this is a representative sample, which I'm assuming the CDC drew, right, Sandra? Good. Now, question. If you had, assuming this was, let's go back to your point, assuming this is a good representative sample, if you had to talk about the average LDL level for American man, what would you say it was?
On average.
On average, what would you say it was? And what measure would you use? I guess that's the question. What measure would you choose to use? So what do you think? Give me your opinion. This is your opinion. This is what it was, your opinion. In your opinion, what measure would you use? And tell me why you think that's okay to use. Be brave. Senator, be brave.
I'd use the large center block.
The large center block?
7.5 and 5.25.
So give it one number, you would call that, I guess we call that 5, right?
5. Call it 5, yeah.
So Senator says to use the large center block, so what measure is she technically using? She's using the mode, isn't she? She's looking at the largest block. Largest block is the most frequent. That'd be the modal entry, right? 4, or 5, excuse me, 5. I love that. I got no problem with that. Anybody want to use the average and not the mode, or the median and not the mode? Median?
I would not want to use the median.
You would not want to use the median. Tell me why you would not.
Because of the 2 lower ones, because it would throw it off.
Ah, you see, the median says we can cancel those 2 lower ones with the ones that are high. I like what you're saying. So let's do that, kids. Let's do that. That's 1 and that's 1, right? Let's cross. Now we've got to cross off 2 of these guys over here, right? Now we've crossed off the 2 extremes, left, down, and up. Now let's cross off the next one over here with that one there that's still there. Let's cross off all 10 of these, 9 of these, and 1 more. So now what I got left? I got this block, this middle block, and this block here. I'm going to cross the rest of this block off, which cancels the rest of this block plus a little bit of this block. And so you see what we just did? The median ends up in the same place Sandra's mode ends up.
So the only time that I guess you wouldn't be able to use median if it was like way far out extreme or something?
Median still wouldn't care about weight. Remember what Linda said earlier about value versus position? The median wouldn't care. Suppose one of these dudes here actually had an LDL of 36.5, and assuming you're still alive. Right? Would the median care about that person? Just cross them off and cross them off the low one, right? Who would care?
That guy.
Yes, well that guy, yeah. The average would care.
The dead guy.
The guy with the 36.5 cholesterol. The average would care, right? The average would move towards that outlier. But there are no, so to speak, outliers right now. There's just a kind of a nice, how would you describe that?
Bell curve.
A nice bell curve, yeah? You see how the left side of the curve is kind of balanced by the right side? Ish. It's not perfect. It's not a perfect bell curve. It's not even as perfect as the ones that I was making in Excel earlier.
Right.
But it's close to a bell-shaped distribution. Now, if you had to give me a number for the average, what would you say it was? A vote for 5?
5.
Vote for 5? Good.
5.
Excellent. Absolutely excellent. Absolutely excellent. I got a hint for you. And this is non-computational, but it's a nice way of approximating an average without actually doing the math on the average. Imagine that distribution of values was a plate of cookies that you had to hold with one hand. Where would you put your hand? Or a finger to balance it? That's where the average, well, define middle. And that's where you're defining, so where would you put your finger to balance the tray of cookies? Tell me where to stop.
Keep going.
About there.
Right there.
Down there? Anybody want me to go further?
That's good.
Somewhere in here?
Yeah.
Yeah.
So you see what you just done? You made me stop at 5. So that that's why when you say middle, the whole point of this topic is central tendency, right?
Right.
But in central tendency in quotes, what are you calling center? We can call the center the most frequent. We can call the center the actual geographic middle, ignoring the true values. Or we can call it middle balance middle. All those mean potentially different things. Not here though. Every single one of those things was the same thing, wasn't it? It was all 5. And that's what part of what I came here to tell you about. When you've got data that's roughly symmetric, which means left and right look basically the same. When it's unimodal, Sandra, you picked out the unimodal right in the beginning. Unimodality, boom, it's got one big bar. When it's unimodal, when it's symmetric, it doesn't matter what you use. Mean, median, mode, they're all going to be about the same value. So pick whatever one's easiest, because you get the other 2 for free. If the mode's easiest, pick the mode and say, oh, by the way, that's the average 2. Now, you might need more precision. If you need more precision, you know how to calculate it, right?
Right.
But if you just need a ballpark to get an idea if something has changed or what the value of something is, it jumps out of the curve, which is so nice. Yeah? Believe it. Not believe it. We believe it, I think, maybe. Questions? Katie, go.
Average, mean, and mode are the same thing? Is that what you're saying?
I'm saying the word average, that's why I keep putting it in quotes.
Okay.
Depending on what kind of average you're doing. So that's why we say mean, median, and mode.
Okay, so it's one
right.
for
Any of all 3, mean,
Okay.
median, and mode, they're all going to be about the same.
Okay, cool.
When you have data shaped like this, which fortunately in statistics you often do. You often get data shaped like this. I say often. I wouldn't call it majority of the time. I call it maybe a plurality. I don't know. Maybe. But sometimes you don't. And sometimes you don't in really cool ways. Like for example, oh, and you're going to have all this, right? This PowerPoint, you're going to have this. So if you don't want to write down the graphs, that's fine. Here's an example. It's a little bit old, but it doesn't matter because it looks almost exactly the same no matter when you check it. These are, let me back this out a little bit. These are for sale house prices in Bend. This was November 2009, so about 5 years ago now. Okay, this is right about after everything kind of collapsed and tanked, and it'd be fun to actually update it and see what they are now. If I can find some time, I'll do that. I gotta feel like I know where it should be. Now remember, this is for sale house prices. This isn't what they're actually selling for. So this is kind of like the wish list pricing, right? They're listing them at this, right, exactly. For sale, yeah, prices. So, but it doesn't matter what the context is. If I asked you, on average, what does one of these houses list at, what would you say? Which measure would you use and why?
Holy crap.
Holy crap.
Not holy crap, but
Holy crap, this is a lot of process.
is it 5.5 and 6?
Oh, thank you, Katie.
Is that
So,
thousands?
just so, yeah, it's
100,000?
hundreds of thousands actually.
Huh.
Just so you know what you're looking at.
Oh.
These cutoffs, the one is 100,000, 150,000, 200,000, 250,000. So these are all the houses between 200 and 250,000. And just so you know, you see how it says outliers removed? 800,000 is mathematically calculated as the highest value that wasn't considered an outlier. There were $14 million houses in this, $18 million houses. This curve actually goes out into the hallway, technically speaking. I cut those off intentionally. I'm going to bring them back in and talk about them in a second too. As Kevin's saying, he's like, okay, I got to film that doesn't end right there. It keeps going. We'll come back and talk about those momentarily, but it brings up the point of what we're making with this. So Katie, that makes sense?
Yeah.
Go, Linda.
I would club them together.
Okay. using the same logic, but just using the clumps we already have here, if that's okay, Linda's saying go with the mode again. So the highest bar, there's 200 houses out of roughly, I think there's about 1,000 that I surveyed. So about 20% or most, the largest percentage between $150,000 and $200,000. So you can call the mode halfway between $175,000.
Yeah.
But clumping is more likely to be accurate because there's still a lot of data.
Sure.
So you want to do something.
But one could argue that clumping it too much gets you too imprecise. If I clump them together again, I might make it so wide. So for example, suppose I clump them by $200,000 or $300,000 increments, then I have to use the middle value in that range, and that might be too far away from precision. Raw data would be best, of course. But if all you have is this, let's not make it even less precise. Does that make sense, Linda? Great point. I love your point. And we had to deal with the clumps. So the mode's a good choice, 175,000. Love it. Sandra, go.
I'd go with the medium this time.
Go with the median. Love it. What would the median be? Now, I'm not going to make us painstakingly go through. Where do you think it is? Kevin.
I would use like your cookie.
Oh, the cookie. Let's come back. Let's come back to you if you don't mind, Kevin. Because that's the average, and Sandra's the median. Let's do one and then the other. So we got the mode of 175. Sandra, what do you think the median is?
I would think it'd be more like 3.
More like 3, somewhere right about here?
Uh-huh.
Because if you chop off all these tails,
Uh-huh.
that would chop off these 2 low bars,
Yeah,
right?
it's gonna move it over.
It's
more.
going to move it maybe that way, so maybe the median's around 3. We won't sit here and painstakingly calculate for 2 reasons. Number 1, I've got the answers here in a minute, because I use it in Excel. And number 2, you know how to do it if you needed to, right? You can do it if you needed to. Kevin, average, go, cookie.
Well, I was actually kind of thinking of like a median.
Oh, you were?
Using that. Yeah, because I was thinking like, okay, like you were saying, chop the tails or stack them up or whatever.
Uh-huh.
Kind of approximate.
I love what you said. Now, this is one of my favorite data sets because, well, where would you think the cookie balance point would be? I'm going to take my hand and start moving it. You guys tell me where to stop. I'll do like a blood pressure reading. I'll mark the lowest and the highest that you guys pick. And we'll see how close you guys come to the actual average. You ready? Here we go.
Right there.
Right there?
There.
There. Yeah.
There?
Just make it.
Okay, there. Okay. So, okay. Hey, this is nowhere near as obvious as the last one, is it?
No.
All of you were within a half of a milligram in the last one. But now it's getting hard because that damn tail, right? Imagine holding a tray of cookies and somebody putting cookies on one side of the tray. You have to keep moving your hand to balance it, right?
Right.
It gets tricky. Here's the actual results. Here's the actual results. The average is actually $300,000. The actual average, now you guys did a pretty damn good job. You guessed from here to here. It's in there. It's in the guesses. 300 grand. The median is at 275. Damn close, Sandra. The mode, you guys nailed, 175. Boom.
Was this this year?
This was 2009. I haven't updated
Oh
it
my
since
God,
09. I
that's like
apologize. Some of the data sets I keep pushing back because
It's like
I'm sure it is. I'm sure it is. Absolutely.
it's horrible.
But now, here's the deal. Here's the deal. Over there on the right, I put all those expensive houses that you can't see on the graph back in and recalculated the measures. Look at that. Look at what the average is when you throw the 18 million and the 14 million dollar houses in. See how it's happening to the average?
Yeah.
30% more.
Be adding that in.
Good question, Rachel. Trimmed mean is sometimes used when you have outliers like this. What it does is it takes a certain percentage and throws away the top and bottom percentage. So it would take the cheapest 5% of the houses and throw them off, and the most expensive 5% and throw those off, and then re-average the rest to get rid of extreme values, if any exist. So it's one way of dealing with extreme values. We're going to learn a couple ways in this class. But you can see what happens when you threw away the extreme values. The average fell from 402 to 350. But that still means that there were more highs than lows. High and low, mathematically calculated. Highs and lows. I'm going to get you guys in 1 second. Just check this out. Look at the median and the mode.
They're the same.
They're the same. Unaffected. It echoes what Linda just said about 5 minutes ago. The median and the mode don't care about those crazy extreme values because they're just out there on the end. They get lopped off or ignored. Now, if we had a spike of 550 at 14 million,
Right.
we'd have a different mode, right? But then you wouldn't call those outliers either. Because you've got 200 or 550, and you're like, what the hell's going on? What mafia boss just moved in and brought his entire family, with us, right? Go, I have questions now. Questions, Dave, go.
I was just gonna say I was surprised that there weren't enough of like multi-million dollar houses to change the median.
Yeah, that's the thing. There weren't that many in that tail. The tail was pretty sparse, and that's the idea. There might be, the median could change a smidge if you've got enough in that tail. The definition of what an outlier is not fixed. Have you heard that? I've used the term outlier like 3 dozen times in this class. You guys have heard it before, yes? Mm-hmm. If you've heard it before, what does it mean to you? Outside the graph, like that. In non-mathematics terms, what is an outlier?
Minority. Extreme.
A minority and extreme. Oh, I like that.
Extreme.
At the fringes, extreme off the graph. At the fringes, extreme in the minority. So what I'm hearing, go ahead, Candace.
Outsider.
An outsider. What I'm hearing is like a rare thing, something that's rare, correct? Mm-hmm. Something that's rare. So Dave, in order for there to be a lot down there, that wouldn't be considered outlierish anymore. There's so many down there that it's a measurable chunk of the graph. There are extreme cases where you can have like 50% outliers, but that's kind of a weird quirk of mathematics that we're going to deal with in this class within 2 or 3 weeks from now. Because there is a mathematical way of calculating what an outlier is. You look at summary stats, you go to the graph and you say, no less than here and no more than here. Everything else is weird. Minority, outlier, outside the realm. But there's a way to calculate that, which is what I did here. Please, Candace.
Is the 5% trimmed for the margin of error? Is that kind of why they did it?
The margin of error, that's actually no margin of error at all in here. I'm not talking about variation at all yet.
No
soon, maybe in 10 minutes. No variation noted on this graph at all. So, I guess the lesson to be learned is what from this?
With outliers, you want to use median or mode.
That's perfectly said, Candace. When you got what's called skewed data, you want to avoid your average because it can mislead. The average is an outlier chaser. It heads. If it gets an outlier, it's like, I want that, 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 I want that. It goes after the outliers. It doesn't focus on the normal chunk. I shouldn't say normal because that has a statistical meaning. It doesn't focus on the typical chunk of the data. It focuses too much on the extremes. Just like the news does sometimes, right? Unemployment's down! No, it's not.
No,
settle down.
because you canceled everybody off.
Well, I'm just saying they jump on what they view to be outliers. Pay attention to the entire data set and not just one piece. That's what I'm getting at. That's what I'm getting at. So, and now skewed, what makes something skewed? So we have a definition without a definition, right?
Impacted.
Say that again. Please, Linda, go.
Just impacted, like.
Yeah, mathematically, I love that definition. Mathematically, this curve back here with the LDL levels has 0 skew. 0-ish skew. Because it's basically symmetric. Skew is the opposite of symmetry. If it's symmetric, left to right is the same both sides. Skew is any deviation from that. Now the question is, what does deviation mean, right? How much deviation? Is anybody thinking that? Oh, you're not. Then don't worry about it right now. Okay. Don't worry about it. We'll develop measures for it, I promise. We'll develop measures for skew. Like, it'll give you a number. Like if it's a -2, it's significantly skewed to the left. If it's +2, it's significantly skewed to the right. If you had to say that one's skewed left or right, what would you say?
Left.
Left. Vote for left? No? Anybody say right? Believe it or not, statisticians call that skewed right.
Because the outliers?
Because where the average would be. The average would chase the outlier. You know where the outliers are. And it's totally counterintuitive to me. I want to call that skewed left. And I ask statisticians, how do you teach your students that that's skewed left? And they say, tell them, think about what they think it should be, and then do the opposite.
That's exactly what I was saying.
And I'm like, tell me why you teach statistics again. So let's just call it skewed. How's that? Let's just, I like to use the word leaning instead of skewed. It leans left. I like that. But just call it skewed. Call it skewed. It's not a bell curve anymore. It's a bell curve that got smushed. And then we can analyze it now. It's not important with the terms anyway. All right, I got one more for us to calculate. If you guys have any more questions about this one? But Candace, you verbalized that perfectly. When you got skew, watch the average. The average can mislead. Aaron, go.
So you just said leaning left, but that's actually skewed right.
It's skewed right, but the word lean I invented. That's not a statistical term.
I know, I'm just saying.
Yeah, leaning left, skewed right. Just call it skewed.
Yeah.
Just call it skewed, leave the direction out. Is that cool? Because there's a calculation later that we'll do that'll take care of the left and right with a negative and positive sign. We can deal with it then. Is that fair? I mean, upset you.
No, I was just,
Yeah, I know. And then as soon as it gets into that kind of discussion, I know I've lost. Because I'm like, oh God, they're missing the big picture, which is when it's skewed, beware the average. That's the big thing. Cool, you got that though. Okay, I have a little question for you guys. I want to show you a graph.